All right, hi. So hopefully you've already watched the recap #1 video that goes over kind of the introductory material of calculus. This is 2017 free response question number 6. This is linked for you to print if you want a hard copy of it. Otherwise, you can just kind of take notes as we go. But this is, I think, a really nice free response question. It represents 3 different equations. So we have f being this function right here. Got a lot of cool trig and a little exponential action. G is differentiable, so remember that means we are going to be able to take the derivative, and we have a table for G and G prime. And then H is our function with a graph, which we have 5 line segments, so that's important because we are able to find the slope of each line up here. We've got H. So again, as always, I like to preview my FRQ so I know kind of what I'm getting into. Find the slope of the line tangent. Okay, so that's just going to be the derivative. Here's some k, and we need to find k prime. Okay, derivative again, looking like a chain rule. This one, m prime, looking like a product rule with a little chain action in there. And then is there a number such that g prime is equal to -4? Well, g prime would be the instantaneous slope. So where the IROC is equal to, I'm going to guess this is the AROC. So we're going to look for the mean value theorem. All right, so let's go step by step. I got each one here on a slide. So find the slope of the line tangent to the graph of f at x equals pi. Well, if we need the slope of f, that means I need the derivative. So here's my function f. So I'm going to take f prime of x will be equal to negative sine of 2x times 2 because of the chain rule, plus the derivative of e to the something is e to the something times the derivative of the something. So if I wanted, this was f prime of x, but they want me to find specifically f prime of pi. So everywhere that I had an x, I am now going to see pi. So negative sine of 2, I'm going to write the pi in just a second once I have my red ink out again. So I got a pi here, and a pi here, and a pi here. All right, so technically, this is now evaluated, and you could stop. But let's show the AP graders that we know our unit circle. So f prime of pi will be equal to, well, the sine of 2 pi is 0. So 0 times 2 is still 0. E to the sine of pi, well, the sine of pi over here is 0. So this is going to be e to the 0, which is really 1, times the cosine of pi is -1. So 1 times -1 is -1. Okay? Part B, let k be the function defined by h of f of x. Find k prime of pi. Well, before I can find k prime of pi, I need to first just find k prime of x. So k prime of x is going to say take the derivative of the outside, leave the inside alone, times the derivative of the inside, just like those peanut M&Ms in your layers. Now I want k prime of pi, so just like on the last one, everywhere I see an x, I now want to see a pi. And remember, this is a free response question, so showing all of your steps and not taking shortcuts is a really good idea. Unlike the last one, I can't just leave this because this is not actually evaluated. I still have some functions in there that I need to work on. So I'm going to start with composite inside out. So f of pi. F of pi is going to require the cosine of 2 pi plus e to the sine of pi. All right, well, cosine of 2 pi is equal to 1 plus e to the sine pi. Sine of pi we said was 0, e to the 0 is 1. So f of pi is going to really be equal to 2. Then I need f prime of pi. Well, conveniently, here's f prime of pi. It's -1 from our previous work, which again is another reason to support actually going through and finding that value instead of leaving things super messy. So this is a -1. So now I'm looking for h prime of 2. Well, here's h. Here's 2. I need to find my slope. Well, the slope of this line is -1/3. So this is -1/3 times -1, which should be equal to 1/3 for our k prime of pi. So again, the calculus that's involved there is really just the chain rule. The rest of it is being able to use your pre-calculus or your AAA knowledge to evaluate all of these composite functions and making sure that you're working from the inside out, right? Pi goes into f, goes into h prime, times pi going into f prime. This would be a situation where, let's say you had found f prime incorrectly in part A, but you used it here, they would still accept your answer for this one. All right, we have m is g of 2x times h of x. Find m prime of 2. Before I can find m prime of 2, I need to just find m prime of x. So I'm going to take the first times the derivative of the second plus the second times the derivative of the first. And that's got a chain rule involved there. So now again, showing all of my work so I don't miss anything. I'm just leaving these blank so I can change my color. That's a negative. All right, it's got 2's going in here. 2 and 2 and 2 and 2 and 2. So m prime of 2 is looking like g of -4 times h prime of 2 plus h of 2 times g prime of -4 times -2. So let's go through and find all these things. G of -4, g was in the table, so g of -4 is going to be 5. H prime of 2, we already found earlier? Yes, we did. H prime of 2 is equal to -1/3 plus h of 2. Well, h of 2, some students got stuck on this one because it's like, oh, I don't really know exactly when there it is. Think about the slope. If this is really -1/3, then for every one box, we go down 1/3. So this would be down 2/3. So -2/3 times g prime of -4. We're still here, but this time we're using g prime. So -1 times, then we still have the -2 just hanging out here. So this is m prime of 2. Again, you could stop here if you wanted, but to clean this up, I've got -5/3 plus -2 times -1 is +2/3 times -2 is going to be -4/3. So this will be -9/3, which means that m prime of 2 is really equal to -3 for the most cleaned up answer. All right, last one. Is there a number c in the closed interval -5 to 5, -5 to -3, I can read, this interval here, such that g prime of c is equal to -4? Well, the first thing you want to look at is just, can g prime ever be -4? And a lot of times you want to look for the intermediate value theorem. Do we go down below -4 and back above it? Not necessarily, right? There's nothing that's guaranteed there by the IVT. So the next thing we could do is figure out the average rate of change and see if it's equal to the instantaneous rate of change. So is A rock equal to I rock? That'll be guaranteed by the mean value theorem because we were told that G was differentiable. So we know we can take the derivative everywhere and we're on a closed interval, right, where we're continuous. So the average rate of change over the interval is going to be, I'm going to use -5, 10 as my first point, and -3, 2 as my second point. So 10 minus 2 is equal to 8. I almost said 5, yikes. -5 plus 3 is going to be -2, which ends up being -4. So is there a number c such that g prime of c equals -4? Yes, because g of x is differentiable, which implies continuity on the function, or sorry, on the interval from -5 to -3, then by the MVT, there exists C on -5, -3, such that G prime of C equals -4. And now this work up here is justifying this -4. If you wanted to, you could write G prime of C equals this difference quotient, and that would be totally okay as well. People always ask, do you really need to write this whole thing out for the mean value theorem? I mean, yes and no. You need to establish why is it okay to be using this theorem. Well, it's okay to use it because of this differentiability implying continuity, and it's concluded because of this work up here, that we've shown that this is true. And so remember, what this means is that the slope of the tangent line will be equal to the slope of the secant line, which means that our two lines are running parallel somewhere on that graph. Okay, so there was a lot of stuff in there, but really in terms of calculus, with the exception of the mean value theorem, we just were applying derivative rules. So make sure that you understand that part, and then go back and maybe make sure you can find all of those values that I kept finding, like h prime of 2 and h of 2 and f prime of pi, right? Like make sure that you can do all of that simplification for yourself in addition to being able to do the calculus part. The next thing then that you're going to try is 2016 on your own. So again, this is available for you to print or have a hard copy of, and then you can check the scoring rubric and see how you did.